Future Now Show. Brought to you by the Club of Amsterdam.
Hey Futurists, it's me, Miss Metaverse. Welcome back to the Future Now Show, brought to you by the Club of Amsterdam. We have a great show for you today. Joining me from London is Steve Hill, project lead at the Major Mouse Testing Program, also known as MMTP. It's a groundbreaking research program that's based in Germany. Hi Steve, how you doing today?
Not too bad.
Thank you for joining us.
Thank you.
And joining us from Moscow is Elena. She's the project coordinator at MMTP. Hi Elena, how you doing?
Hello, it's a little cold in Russia.
Is it? All right, so I have a couple questions for you. I know we don't have a whole lot of time, but Steve, let's start with you. So would you please share a little bit of a background on MMTP? Where did the idea for this research project come from?
It's a good question. I mean, basically, the idea behind it comes from the fact that for a long time people have always thought that aging was sort of an immutable process. You know, it can't be stopped; it's inevitable. But the weight of scientific evidence, you know, in recent decades is you know, definitely against that. It's supporting that aging is something that can, you know, is amenable to intervention. And you know, we thought it was time that something was done about it. We know that aging, you know, the aging cell and tissue is a primary risk factor for you know, all sorts of sort of age-related pathologies and diseases. So what better place to intervene than actually on the process itself? So that's where we come in, and a lot of research has shown, you know, different things like rapamycin and all that sort of thing, metformin. Various compounds have been shown to sort of increase health span and lifespan in model animals, mice in particular, but other animals. What we want to do is we want to ask the obvious question: can we translate that to humans? And really, the way to do that is to test it robustly, look at the promising compounds, and get the data, and then say, look, you know, this is something we can do. Here's the proof. Here's the evidence. Let's take it to the next step. So that's really what the MMTP is about: getting that initial bench work done, and then with an eye to translating it to clinical trials.
Excellent. Very exciting stuff. It really is. And Elena, what is your reasoning behind joining this project? Or what inspired you?
Well, in fact, I'm working on longevity project of different kinds for several years, and the last year, together with the colleagues from a local non-governmental organization, we conducted a study of different barriers that slow down the development and the implementation of new biomedical technologies. And so we found out that, in fact, the system of state support for these technologies, and especially for fundamental gerontology, is not very friendly. And at the same time, the big pharmaceutical companies are not very keen to test so-called high-risk interventions, and they don't like the feeling of uncertainty. And so probably the best way to help the research is to crowdfund for it, and to help the scientists to get the money they need basically for this research. We find it really attractive for two reasons. First of all, for the scientists, there is much less paperwork than during the normal grant work. And the second reason is that basically we can give any person on the planet the opportunity to decide for themselves what kind of experiments they believe are the most important for the future well-being. And to me, for instance, this opportunity is really important.
Excellent. That's great. Well, so let's talk about MMTP, where you're based, and why are you based where you're based. Steve, tell me about it.
There's a lot of base in there, but yeah, we are based. Well, the initial phase of the experiments will be at Leipzig University. It's a very prestigious university. They've got excellent facilities. So that's really one of the main reasons why we chose that university. We spent over a year looking at different places, talking to different researchers, to decide. So it's not something that we've rushed into. And Leipzig sort of ticked all the boxes. They've got very high quality laboratory, excellent facilities, good standard of welfare. So we thought it was the best place to sort of start, as it were. It's not going to be the only place, because we're talking to other labs. We're sort of thinking about collaborating as well for later stages. But for us, it was a bit of a no-brainer, really, for us to go with Leipzig. As to what we're testing, well, we're going for some, well, I like to think it's kind of low-hanging fruit. We're going for senolytics. It's a big hot topic right now. Scripps Mayo's talking about it. It's all over the news. Campisi's lab. Everybody's talking about it at the moment, so it's really hot. But basically what we're doing is we're going after the zombie cells, as some people call it. They're sort of death-resistant senescent cells, and removing them has been demonstrated to improve health. Very recently, a couple of weeks ago, a paper showed a good improvement in vascular health and reversal of some of the signs of vascular aging, which is very promising, obviously. And we think not only will it improve health, we think it would probably increase lifespan. All the signs that it does are already there. They've used a P16 knockout mouse, which they could switch the cells on or off, literally, very recently, the same group. And when they switched these senescent cells off, it did increase the lifespan by about, I think it was 25–30%. That's not too shabby. And the main reason why we're going after it as well is because we think it's got a very high chance of translating directly to humans. And it's simple. Because humans get senescent cells, and they build up and they increase and cause tissue dysfunction. Mice get them, rats get them, rabbits, dogs. Every sort of organism in that chain gets them, and it is a problem. And removing it is very likely to be beneficial to humans. So hence I say it's a low-hanging fruit, and I think it's the obvious choice for us to start on.
And from what I understand, you're not just using any kind of mice, right? You're using a certain kind of mice?
Well, yeah. We're actually using Black 6, which is pretty much the sort of standard currency for lab mice, if there was such a thing. The people say, oh, well, why Black 6? Well, the reason is because they're not really special at all. And that's a good thing, because we don't want a mouse that's bred to have a particular sort of trait or characteristic. It's got a few, but there's nothing really that's going to affect its ability to be a very good model for aging research, and that's why we've chosen it. And a lot of studies, thousands upon thousands, already have used it. It's very well known. It's been sequenced fully, so we understand how that mouse works to the highest degree. So for us, it was the obvious choice, and plus they're easy to get a hold of. Not cheap, but they're easy to get.
Well, we appreciate all of your hard work, and it's important. It's really important. So now we need to talk about how we can help you make this a reality. We the people, we the public. How can we help you bring this vision of yours to life? Elena, I want to ask you. So you're in charge of the funding. You're handling that, and you are choosing to go through crowdfunding. So what kind of results are you looking to achieve with your crowdfunding campaigns and through your funding?
Well, at the first stage of this project, we will need about 50,000 euros. It will allow us to test a combination of two promising interventions. And this price also includes the post-mortem analysis. And this thing is very important because we want to get as much data on the changes in the animal health as we can. And this kind of analysis will allow us to learn how exactly the mortality of animals from different age-related diseases has changed during the experiment. What is the share of different age-related diseases in the mortality, and how much this share can be different from the, from the norm. We are also are going to examine the effects of senolytic on stem cells. Nobody has done it before, so we believe we can get a lot of interesting data, and our chief researcher is in a best place to do that because this is her general specialization. So we do not yet the results. Let's try to find out. And in case we're be able to collect more money, like say 2 to 50,000 more than our goal is, then probably we are going to test another combination.
All right, so Steve, you're launching a crowdfunding campaign in April, and you've chosen an interesting platform to do so. Would you please tell us about lifespan.io?
Yeah, can do. Well, lifespan.io is a bit like Indiegogo or Kickstarter, that sort of thing. It's the idea being you can fund your own projects and people can donate and get involved. The interesting thing, or at least interesting for me, about Lifespan is clues in the name. Really, it's all about longevity research. It's exclusively focused on that side of things. So we're looking at aging research and longevity. Sen's research have already launched a overly successful campaign on there, and that was for mitochondrial. It was a mitochondrial project, which is very important for aging. We're not working on that ourselves, but a lot of plates to spin. I mean, David Sinclair's got another project about to launch as well. So for us, it was a sort of obvious place to go, especially as a first outing. We're hoping once we gather steam as a project, we can sort of cast a wider net, and obviously what we're doing has implications for things like heart disease, Alzheimer's, all those sorts of things, that are associated with aging and senescent cells. So we can effectively try and pull more people in. But what we've got to do at first is we've got to get that first sort of outing, improve ourselves. So for us, it was the obvious choice to go with Lifespan. Plus, they're really cool guys. They're a lot more hands-on than Indiegogo and Kickstarter, where effectively you're pretty much left to it. Not that there's anything wrong with them platforms, but for something like this important, for such a what I would call a niche field, we thought we needed to hit it like a battering ram. So we went for the obvious choice. We're taking no prisoners.
Well, we're definitely excited to see the crowdfunding campaign come out. I know I can't wait to be a supporter. And Elena, so here's a question that I've been very much looking forward to asking. And so as women, we're constantly bombarded with expensive and sometimes painful anti-aging cures and procedures like facelifts, Botox, fillers, diets, and lasers. It's crazy, and it's so much money. So how might MMTP's research change the ways that we combat aging in the future?
Well, MMTP is aimed to make the complex interventions to get available as fast as possible. But if anyone is anticipating one universal pill against all the aging related processes, this is not going to happen very soon. I'm pretty sure about that. Most probably the approach to slow down aging and to stay young in the next few decades will be a kind of a combination of diet, sports, and pills and vaccines, and also cell therapy and gene therapy, obviously. This sounds kind of complicated, but in fact the developers will try to make the healthcare services more client-friendly in the next years, and I believe that in future we are going to wear some kind of health bracelet on our wrists, which will monitor our health parameters and will react to any kind of biomarkers of aging, to react right away by injecting in our blood some kind of remedies right away. So it will be pretty easy, but we will have to wait for these kind of things to develop. And then, well, it will be very nice because you will just need to wear this kind of bracelet from time to time, and you are going to look young and strong and healthy as a young person, even in your 90s.
Oh, I can't wait for that.
Send me one.
the ideal situation.
I'll take 2.
I'll take 3. All right. So, Steve, are there any more thoughts that you'd like to share before we go?
I mean, it's a pretty simple one, really. The take-home message really is no mice, no men. It's essential that this sort of basic research is funded. We need to get the answers. We need to get that data. And without that data, we're not going to be able to move into human clinical trials. The FDA, the EMA, and various other government agencies all require robust animal data prior to testing any new drugs or interventions. So it's as simple as that, really. The take-home message is support the basic work, and we'll get it done. You know, I often say that science. It's about sexy science, and I've said that before. But most people don't really sort of regard mouse research as what I would call sexy science, and that's the problem. There's a real disconnect between what goes on at the bench and drugs and things get into the bedside. I admit it's probably not the most sexy subject, but it's the most important one. People need to understand that link, and they need to support it. Otherwise, no mice, no data, no human trials, no anti-aging drugs, and that's it. Simple as that.
Great. Well, thank you so much. And Elena, is there anything else you'd like to share with us before you go?
Well, I pretty often I hear a question about, we are going to get bored about our very long life. But in fact, I believe that this world is a nice place and very diverse and very surprising. And when I'm working to give people more years of healthy and productive life, I'm most of all inspired by how many new opportunities they can have and how many new life experiences they can have. And really, I hope that we might get all these new technologies much faster if we put some more common effort to live longer.
That's excellent. Well, thank you so much for joining me today. I'm very excited about our incredible future. We'll be able to live longer, be healthier. And for more information about the Major Mouse Testing Project, we're going to be including links below in the description. And, well, thank you both for joining us today. Such a great show. So excited.
Thank you.
Thank you.
Now let's go build a better future. Yes. All right. Take care. Bye. Thank you.